Welcome dear audience, students and scholars. Here I'm Dr. Amjad Ali. In this video we will provide introduction to statistics as a subject. Dear scholars, the study of statistics has become more popular than ever over the past 4 decades or so. The increasing availability of computers and statistical software packages has enlarged the role of statistics as a tool for empirical research. As a result, statistics is used for research in almost all professions, from medicine to sports. Today, college students in almost all disciplines are required to take at least one statistics course. Almost all newspapers and magazines these days contain graphs and stories on statistical studies. After you finish this course with me, it should be much easier to understand these graphs and stories which are given in newspapers and magazines. Dear scholars, every field of study has its own terminology. Statistics is no exception from this. This introductory session explains the basic terms of statistics. These terms will bridge your understanding of the concept and technique presented in our subsequent sessions. In this particular video, we will cover the content. First, we will define what is statistics as a subject, as a word. Then we provide the types of statistics. Population versus sample, these two are extensively discussed words in statistics. Then we provide some basic terms related to the statistics. Types of variable will be discussed here, and we provide the difference between the cross section and time series data. And then we provide the sources of data. These sources of data are somehow related to the US economy, and there are some other international and some other countries' national data sources which are not subject to the study of this course or this video. And then at the end we will provide the summation notation. Somehow this is the starting point for the formulation of statistic as a subject. Now discuss word what is statistic. The word statistics has two meanings. In the more common usage, statistic refers to numerical facts, the number that represents the income of a family, the age of a student, the percentage of passes completed by a quarterback by a football team, and the starting salary of a typical college graduate are the example of statistic in the sense of word. The second meaning of statistics refer to the field or discipline of the study. So overall, the definition of statistic is a group of methods used to collect, analyze, present and interpret data and to make decision. Dear scholars, in every day we make decision that may be personal, business related or some other kind. Usually these decisions are made under conditions of uncertainty. Many times the situation or problems we face in the real world have no precise or definite solution. So statistic as a method helps us make scientific and intelligent decision in such a situation. Decision made by using the statistical methods are called educated guess, while decision made without any usage or without using statistical methods are pure guess and hence may prove to be unreliable. For example, opening a large store in an area with or without assessing the need for it may affect its success. Okay, let's discuss some of the aspects of statistics. Like almost all fields of study, statistics has two main aspects: theoretical and applied. Theoretical or mathematical statistics deal with the development, derivation, and proof of statistical theorems, formulas, rules, and law. While applied statistics involve the application of those theorems, formulas, rules, and laws to solve real-world problems. In this video or in this statistical course, we mainly concerned with applied statistics, not with theoretical or mathematical statistics. By the time you finish this course, you will have learned how to statistical methodologies and how to make educated guesses. Types of statistics. Broadly speaking, applied statistics can be divided into two areas. The first one is descriptive statistics and the second one is inferential statistics. Okay, let me explain the detail of descriptive statistics. Suppose we have information on the test score of students enrolled in a statistics class. In statistical terminology, the whole set of numbers that represent the scores of students is called a data set. The name of each student is called an element, and the score of each student is called an observation. A data set in its original form is usually very large. Consequently, such a data set is not very helpful in drawing conclusion or making decision. It is easier to draw conclusion from summary tables and diagrams or graphs than from the original version of a data set. So we reduce data set to a manageable size by constructing tables, drawing graphs, or calculating summary measures such as average. The portion of statistics that helps us do this type of statistical analysis is called descriptive statistics. Okay, then the overall definition of the descriptive statistic. The descriptive statistics consists of methods for organizing, displaying, and describing data by using tables, graphs, and summary measures. So let's explain the concept of inferential statistics. In statistics, the collection of all elements of interest is called a population. The selection of a few elements from this population is called a sample. A major portion of statistics deal with making decisions, inferences, predictions, and forecasts about populations based on results obtained from sample. For example, we make some decision about the political views of all college and university students based on political views of 1,000 students selected from a few colleges and universities. As another example, we may want to find the starting salary of a typical college graduate. To do so, we may select 2,000 recent college graduates, find their starting salaries, and make a decision based on this information. The area of statistics that deals with such decision-making procedures is referred to as inferential statistics. This branch of statistics is also called inductive reasoning or inductive statistics. So overall, the definition of inferential statistic. Inferential statistic consists of methods that use sample results to help make decisions or predictions about population. Okay, let's discuss the word or the concept or difference between population versus sample. Dear scholars, we will encounter the terms population and sample on almost every page of statistics books. Consequently, understanding the meaning of each of these two terms and difference between them is crucial. Suppose a statistician is interested in knowing the percentage of all voters in a city who will vote for a particular candidate in an election. The 2009 gross sales of all companies in any particular city, the prices of all houses in particular city. In these type of example, the statistician is interested in all voters, all companies, and all houses. Each of these groups is called the population for the respective example. In statistics, a population does not necessarily mean a collection of people. It can in fact be a collection of people or of any kind of item such as houses, books, television sets, or cars. The population of interest is usually called the target population. So let me define the definition of population. A population consists of all elements, individual, items, or objects whose characteristics are being studied. The population that is being studied is also called the target population. Most of the time we make decisions on the basis of the portion of population. For example, the election polls conducted in any of the country to estimate the percentage of voters who favor various candidates in any local or national level elections are based on only a few hundreds or few thousand voters selected from across the country. In this case, the population consists of all registered voters in a particular country. The sample is made up of a few hundreds or few thousand voters who are interested in an opinion poll. Thus, the collection of a few elements selected from a population is called sample. So let me give the definition of sample. A portion of population selected for a study is referred to as a sample. Okay, let's see the graphical presentation for the sample and population. Like as we have discussed about the population is all items or subject which are we interested to study, and we are making normally decision based on some of the selected part from this population. So population covers the whole items or selected or interested target population, and from this some of the individuals or some of the items are selected and we make the decision on the basis of this sample. Okay, let me give you some information about the survey and census. The collection of information from elements of population or a sample is called a survey. A survey that includes every element of the target population is called census. Often the target population is very large, Hence, in practice, a census is rarely taken because it is expensive at an individual level, and moreover, it is time consuming. In many cases, it is even impossible to identify each element of the target population. Usually, to conduct a survey, we select a sample and collect the required information from the selected elements included our target sample. We then make decision based on this sample information. Such a survey conducted on a sample is called sample survey. As an example, if we collect information on let's say 2020 incomes of all families in a particular city, it will be referred to as a census. On the other hand, if we collect information on 2020 income of only 50 families from that particular city, it will be called a sample survey. So let me give the definition of the survey and census. A survey that includes every member of population is called a census. The techniques of collecting information from a portion of population is called a sample survey. The purpose of conducting a sample survey is to make decision about corresponding population. It is important that the results obtained from a sample survey closely match the results that we obtain by conducting a census. Otherwise, any decision based on a sample survey will not apply to the corresponding population. As an example, to find the average income of families living in a particular city by conducting a sample survey, the sample must contain families who belong to different income groups in almost the same portion as they exist in the population. Such a sample is called a representative sample. Inferences derived from a representative sample will be more reliable. So we have a sample that represent the characteristics of the population as closely as possible is called representative sample. Okay, a sample may be random and non-random. In a random sample, each element of population has a chance of being included in sample. However, in a non-random sample, this may not be the case. So a random sample, a sample drawn in such a way that each element of population has a chance of being selected is called a random sample. If all samples of the same size selected from a population have the same chance of being selected, we called it simple random sampling. Such a sample is called a simple random sample. One way to select a random sample is by lottery or a draw. For example, if we are interested to select 5 students from a class of 50, we write each of 50 names on a separate sheet or a piece of paper. Then we place all 50 slips in a box and mix them thoroughly. Finally, we randomly draw 5 slips from the box. The 5 names drawn given a sample that is a random sample. On the other hand, if we arrange all 50 names alphabetically and then select the first 5 names on the list, it is a non-random sample because the students listed on 6th and 50th number have no chance of being included in sample. There are 2 main types of sampling that is sampling with replacement and sampling without replacement. So let's define sampling with replacement. In sampling with replacement, each time we select an element from the population, we put it back in population before we select the next element. Thus, in sampling with replacement, the population contains the same number of items each time a selection is made. As a result, we may select the same item more than once in such a sample. For example, consider a box that contains 25 marbles of different colors. Suppose we draw a marble, record its color and put it back on the box before drawing the next. Every time we draw a marble from this box, the box contains 25 or whatever the number, total number we have, the marble pieces. This is an example of sampling with replacement. The experiment of rolling a die many times is another example of sampling with replacement, because every roll has the same 6 possible outcomes. Sampling without replacement. Sampling without replacement occurs when the selected element is not placed in the population. In this case, each time we select an item, the size of the population is reduced by 1 item. Thus, we cannot select the same item more than once. In this type of sampling, most of the time, samples taken in statistics are without replacement. For example, consider an opinion poll based on a certain number of voters selected from a population of all eligible voters. In this case, the same voter is not selected more than once. Therefore, this is an example of sampling without replacement. So let's discuss some of other basic terms used in statistics. It is very important to understand the meaning of some basic terms that will be used frequently in our statistics course. In this video, we explain the meaning of an element, a variable, an observation, and a data set. An element and a data set we have somehow discussed in our previous few slides back. So here we have a graphical presentation for this purpose. We have here a charitable givings of 6 retailers in 2007. So here we have around 6 different companies or firms. We can call this group of companies a sample of 6 companies. Each company listed in this table is called an element. We can say these are the elements or member of our sample analysis. And the information contained on 6 elements, here we have the information that is an observation or measurement of this unit. So we have here the definition of element. An element or a member of a sample or a population is a specific subject or object. For example, a person, firm, item, state, or a country about which the information is collected. So here we have the information related to the charitable giving in our example, and that information is called a variable. So here we have that information is variable. Here we have the 2007 charitable giving is a characteristics of a company that we are investigating or study. So let's define the word variable. A variable is a characteristics under study that assume different values for a different element. In contrast to a variable, the value of a constant is fixed. In general, a variable assumes different values from different elements, as we have discussed in our last example that is related to the 2007 charitable giving of 6 companies for some elements in data set. However, the values of the variable may be the same. For example, if we collect information on income of household, these households are expected to have a different income, although some of them may have same income. So a variable is often denoted by x, y, or z. For example, in our example here, we have, in this example, we have somehow denoted our variable with any other letter, but here we have given it a charitable or given the full name of our variable. So you can put the name of your variable by x, y, or z. Okay, so each of the value representing in our example of 6 companies are somehow called the observation or measurement of our variable. So here we have the complete definition of observation or measurement and data set. The value of a variable for an element is called an observation or measurement. As we have discussed in our example, let's say if the firm A has such amount of charitable expenditure, and the value that we have highlighted is an observation or a measurement of that particular variable. So every 6 firms or companies which we have included for our analysis, these are all the observation for our analysis. So and a data set is a collection of observation on one or more variable. Okay, let's discuss about the types of variable. Variable, as we have discussed, that is a characteristic under investigation that assume different values for different elements. The incomes of a family's, heights of a persons or different persons, gross sales of different companies, prices of college textbooks, mix of cars owned by families, and number of accidents, and status of students enrolled in a university are some of the examples of a variable. There are somehow 2 main types of variable: quantitative variable and qualitative variable. So let's explain first the quantitative variable. Some variables such as the prices of a home can be measured numerically, whereas other variables such as hair color or love cannot be measured in the form of numerical or numerical numbers. Quantitative variables. Some variables such as the price of a home can be measured numerically, whereas other variables such as hair color or love cannot be measured in the form of number. The first is an example of quantitative variable, and the second that of a qualitative variable. A quantitative variable has a definition like that. A variable that can be measured numerically is called a quantitative variable. The data collected on a quantitative variable are called quantitative data. For example, income, height, gross sales, price of homes, number of cars owned, and number of accidents are the example of quantitative variables because each of them can be expressed numerically. For example, the income of a family may be 50,000, 60,000, or 70 or 100,000. And the gross sale for a company may be 100 million, 200 million, 500 million for the past year, and so forth. Such quantitative variables can be classified as either discrete variable or continuous variable. So let me define or give the definition of the discrete variable. A variable whose values are countable is called a discrete variable. In other words, a discrete variable can assume only certain values from no intermediate values. So the value of a certain quantitative variable can assume maybe countable or non-countable. For example, we count the number of cars owned by a family, but we cannot count the height of a family member. A variable that assumes countable value is called a discrete variable, as we have given the example. For example, another example that is the number of cars sold on any day at a car dealership in a discrete way. So because the number of cars sold must be 0, 1, 2, 3, 4, so on, and we can count it. The number of cars sold cannot be between 0 and 1 or between 1 and 2. Otherwise, the discrete numbers cannot be achieved. So variables are the number of people visiting a bank on any day is also a discrete variable. The number of cars in a parking lot, the number of cattle owned by a farmer, and the number of students in class. These are some of the other examples of the discrete variable. We have another variable that is a continuous variable. So sometimes variables cannot be counted and they can assume any numerical value between two numbers. Such a variable is called continuous variable. A variable that can assume any numerical value over a certain interval or intervals is called a continuous variable. The time taken to complete an examination of is like an example of a continuous variable. It can assume any value, let's say between 30 and 60 minutes. The taken time by we can say that 42.6 minutes, 42.67 minutes, are so like these type of numbers are called the continuous variables number. So let me give you some other definitions of variable that is quantitative or qualitative variable. So a variable that can be measured in the form of number is called the quantitative variable, but a variable that cannot be measured numerically, but we can divide into different categories, that is our qualitative or categorical variable. So a variable that cannot assume a numerical value but can be classified into two or more non-numerics category is called a qualitative or categorical variable. The data collected on such a variable are called a qualitative data. For example, the status of an undergraduate college student is a qualitative variable because a student can fall into any one of four categories, like maybe freshman, sophomore, junior, or senior. There are some other examples of qualitative variables are the gender of a person, the brand of a computer, the opinion of people on a certain National Assembly member, and the like or dislike of a person for a particular car brand. And here we have the graphical presentation for our variable. We have two main types of variable, quantitative and qualitative or categorical variable, and we can uh, 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 disaggregate the type of quantitative variable into discrete variable and continuous variable. Okay, let's discuss about the other main content of today's discussion, that is the difference between the cross section and time series data. So let me first explain the cross section data. Cross section data contains information on different elements of a population or a sample for the same period of time. The information on income of 100 families for 2020 is an example of cross section data. All examples of data already somehow we will present in our coming session with further numerical discussion. Okay, the cross section data, the data collected on a different elements at the same point in time or for the same period of time are called cross section data. So here we have a numerical example for this purpose. We have the charitable givings of 6 retailers in 2007. So we are getting the data of 6 different companies or firms at one point of time, and our one point of time is 2007. So this is our cross section data example. Time series data. Time series data contains information on the same element for different periods of time. Information on any type of variable, that may be the exports, imports, for the over the time when we get this information is an example of time series data. So the definition of the time series data: data collected on same element for the same variable at different points in time for different periods of time are called time series data. Here we have the data for empirical example, that we have the number of movie screens. Like the data in this table give us the information that the total number of indoor movie screens in a particular country or a city for the year 2003 to 2008. Note that each screen in each theater counts as one. For example, we have movieplex with 8 screens would count as 8 towards the number of screens. So here we have a country or maybe a continent, maybe a city, different screens are data is available. So somehow this is our time series data. Data sources. Okay, data sources are sources of data. The availability of accurate and appropriate data is an essential for driving reliable result. So data may be obtained from internal sources External sources are a survey and experiments. Many time series data come from different internal sources such as company personal files or accounting record. For example, a company that wants to forecast the future sales of its uh, product may use the data of past period from its record. For most studies, however, all the data that are needed are not usually available from internal sources. In such cases, one may have to depend on outside sources to obtain data. These sources are called the external sources. For example, the statistical abstract of United States, which contain variables of different kinds of data on the United States, is an external source of data. A large number of governments and private publications can be used as an external source of data. So here we have some famous or external data sources, that is statistical abstract of the United States, employments and earnings, handbook of labor statistics, source book of criminal justice statistics, economic report of the president, county or city data book, state and metropolitan area data book, and digest of education statistics, health United States, and agriculture statistics. These are somehow our main data source that are specifically related to the United States. And if we want some other country data source, so there may be a chance that statistical abstract of United States provide some other country data related to the particular variable. But the data sources like World Bank, IMF, these are some international data sources that provide the information on a country basis, on a region basis, or somehow on the continent basis as well. Explain the last topic of our today's discussion. Sometimes mathematical notations help express a mathematical relationship concisely. This section describes the summation notation that is used to denote the sum of values. Suppose a sample consists of 5 literary books and the prices of these 5 books are $75, $80, $35, $97, and $88 respectively. The variable price of a book can be denoted by X. Like we have book 1, book 2, book 3, 4 and 5. The prices of book 1, 2, 3, 4 and sum of 5 books is $375. The uppercase Greek letter summation or pronounced a sigma is used to denote the sum of all values. Using notations, we can write the foregoing sum as follows. So we have summation x is equal to it is the sum of x1, 2, 3, 4 and 5, that is equal to $375. Okay, the notation summation x or sigma x is in this expression represent the sum of all the values of x and is read as sigma x or summation x. Somehow sigma x or summation x are some of the values of x. So this is all about some of the introduction or some of the terminologies used extensively in statistics. We have somehow discussed the word, what is statistic, type of statistic, population versus sample, the basic terms, types of variable, cross section versus time series data, sources of data, and at the end we have discussed summation notation. In coming session we will discuss about the empirical part of these terminologies and these methods. So see you with another video. Ciao.